Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the today's session on sampling distribution part 6. Let us recall the previous session. In the last session, I have introduced the sampling distribution and discussed about different types of sampling distribution. In sampling distribution, there are many different types, such as sampling distribution of means, sigma known, sampling distribution of proportions, sampling distribution of sums and differences. And in today's presentation, in today's session, I would like to introduce the sampling distribution of means when sigma is unknown. That means when the standard deviation of population is not given, then we use the t distribution. Here we introduce the t distribution. So, in the case of sampling distribution of mean sigma is unknown, we introduce t distribution. So, in the today's session, we introduce t distribution and then we discuss about the t curve and t distribution table and solve some simple problems also. Now, sampling distribution of mean sigma unknown. If the population standard deviation sigma is unknown, then we replace it by the sample standard deviation S. So, if sigma is not given, we can replace it by sample standard deviation. And the random variable follows t distribution with n-1 degrees of freedom. And hence, we denote this random variable by t equal to x bar minus mu by s by root n. For example, if sigma is known, that means in the previous session, we discussed about the sampling distribution of means when sigma is known. If sigma is known, then the random variable is z equal to x bar minus mu by sigma by root n. If sigma is unknown, simply replace it by sample standard deviation s and the variable is t that follows t distribution with n-1 degrees of freedom. Not only that, in the case of small sample means n less than 30. So, if n is less than 30, then we use t distribution. So, either in the case of sigma is unknown or n is small, we introduce t distribution. And this t distribution is called student's t distribution or simply t distribution. When we deal with a sample that is n less than 30, that means with a small sample, when we deal with a small sample that is n less than 30, then we use t distribution. Let x bar be the mean of random sample of size n, which is less than 30, drawn from a normal population with mean mu and standard deviation sigma. If this sigma is not given, we replace it by s. If sigma is given, even though for small samples, we use the t distribution. So, for small samples, S will be calculated using the given data of the sample. So, the variable t is given by x bar minus mu by s by root n, where t is called the value of t or t score, x bar the sample mean, mu population mean, s standard deviation of sample, n sample size. Now, student t distribution, also known as t distribution, is a probability distribution that is used in statistics for making inferences about the population mean when the sample size n is small or when the population standard deviation is unknown. So, we use this student t distribution when the size of the sample is small, that is n less than 30, or else the standard deviation of the population sigma is unknown. Next, it is similar to the standard normal distribution, Z distribution, and the theoretical work on this distribution was done by W.S. Gossett, and after his findings, he used the pen name student. That's why this distribution is called student's t distribution or simply t distribution. The t score represents the number of standard deviations the sample mean is away from the population mean. The number of sample deviations the sample mean is away from the original population mean. So, the t score represents this value, and t score is also known as the t value or t statistic which is a standardized score that quantifies how many standard deviations a data point or sample mean is from the population mean. So, the same point is discussed here again, and it is commonly used in statistical hypothesis testing, particularly in scenarios where the sample size is small or the population standard deviation is unknown. Now, coming to t-distribution curve and the properties of t-distribution. So, this is the t-distribution curve. Here, this axis is t-axis and this is f of t-axis, and t-distribution curve is similar to the normal curve. It is bell-shaped curve, symmetric about the mean mu equal to 0. It is unimodal, that means the mean, median and mode coincides, asymptotic on both sides of t-axis, and the t-curve is similar to normal curve, where the variance of normal curve is 1, whereas here for t-distribution it is more than 1. Similarly, the t-score or t-value depends on mu, the degrees of freedom. So, t depends on mu, the degrees of freedom given by mu equal to n minus 1. So, n minus 1 degrees of freedom. And critical values of t distribution are denoted by t alpha. So, we denote the values by t alpha, where alpha is the area under t curve. So, the critical values are denoted by t alpha. And for example, if we denote t alpha, that means the area to the right side of t is equal to alpha. For example, here if I write t alpha, this area is equal to alpha. So, in t alpha, alpha denotes the area right to t value. Similarly, in minus t alpha, if I consider minus t alpha here, this alpha denotes the area left to that negative value. So, if the t value is positive, alpha is the area which is right to t. If t is negative, then alpha is the area left to t. These two are important points using which we can find the area using t distribution table. So, there is another important property, t1 minus alpha is minus t alpha. So, t1 minus alpha equal to minus t alpha. For example, sometimes if it is required to find 0.995, you cannot find this value in t distribution table. So, what we do here, we write this in terms of 1 minus something, and which is equal to, for example, 1 minus alpha, which is equal to minus t alpha. So, this t alpha can be obtained using the t distribution table. The t distribution, the critical values of t are tabulated in table which is called t distribution table, and the t distribution is extensively used in the testing of hypothesis about one mean or about equality of two means. So, to test the hypothesis about a single mean, one mean or difference of two means, so two means problems, we use t distribution for small samples in testing of hypothesis for one mean and two means. Now, coming to this t distribution table, here in t distribution table, the table is given here. In this table, the left hand column contains the values of mu. So, you see this left hand column, degrees of freedom, this denotes mu. The left hand side column or leftmost column denotes the values of mu, the degrees of freedom. And the top row or column headings are the areas or probabilities. So, here 0.25, 0.2, 0.15 and so on, these are the areas, alpha values, and the entries are t values. Entries means these values. So, corresponding to this degrees of freedom mu, we can find the area to the right of a positive value of t or area to the left of a negative value of t. Similarly, if we have the area, we can find the corresponding t value also using this t distribution table. So, here the leftmost column denotes the degrees of freedom, top row or column headings are areas or probabilities, and entries are the t values. Now, using this t distribution table, we can find the area under the t curve. So, if we have the value of t, we can find area. If t is given, then you can find alpha. If alpha is given, then you can find the value of t also. And the main value is the degrees of freedom mu, degrees of freedom n minus 1. Mu is the degrees of freedom given by n minus 1. So, t value depends on these degrees of freedom. Now, let us solve some problems. Find t 0.25 when n equal to 15. So, here the main thing is in T alpha, alpha is the area or probability. First we should know the notation first. T is the critical value of T, or which is called T score. N size of the sample, if we have this n value, we can find the new value, the degrees of freedom given by n minus 1. So, in the first problem, n equal to 15. If n is 15, what is the value of nu, degrees of freedom? Nu is, if n is 15, nu is n minus 1. So, 15 minus 1, 14 degrees of freedom. And t 0.25, this is the required one to calculate. So, that means in T alpha, alpha denotes the right side area. So, alpha equal to 0.25. Now, what is the value of T? So, if we draw this T curve, so this is some T 0.25. What does it mean? The area to the right side of this T value, this is 0.25. Then what is the value of T? So, from the table, T distribution table, we can find this T value corresponding to mu equal to 14 degrees of freedom and alpha equal to 0.25. So, let us go back to the T distribution table. So, for mu 14 degrees of freedom, alpha is 0.25. So, 14 degrees of freedom and 0.25. 14 degrees of freedom and then, so 2.145. So, for 14 degrees of freedom, T 0.25 is 2.145. Similarly, we can find the remaining values also. So, in the first problem, the areas are given, we need to find T value. So, second, minus T 0.01 when n equal to 11. So, n equal to 11, that implies nu is n minus 1, 10 degrees of freedom and alpha is 0.01. Simply it is a negative value. This minus T 0.01, it is a corresponding negative portion. So, we need to calculate this value when n equal to 11. So, no need to use any formula here. We use that property when the value is more than this 0.2 or 3. So, for example, T 0.99 is given, then we use that particular formula. Here T 0.01 is available in the T distribution table itself. So, we do not use that property here. Directly we can find T 0.01. Let us go back to T distribution table and check for n equal to 11 means nu equal to 10 degrees of freedom and 0.01. 10 degrees of freedom 0.01. 10 degrees of freedom 0.01. 2.764. So, minus T 0.01 is minus 2.764. And the third one, you see in the third problem T 0.995 is given. So, T 0.995 when n equal to 8. So, if n is 8, the degrees of freedom nu is n minus 1, which is 7 degrees of freedom, and from using the property T 1 minus alpha is minus T alpha, this T 0.995 can be written as T 1 minus 0.005. So, for 7, which is equal to minus T 0.005. So, for 7 degrees of freedom, minus T 0.005 from the T distribution table. 7 degrees of freedom and 005. 7 degrees of freedom and 005. So, this value 3.499 minus 3.499. So, like this we calculate the T values if areas are given. Coming to the second problem, here we need to find the area such that the probability of T lies between two values are less than or greater than. So, in the second problem the values of T are given, we need to calculate the area. Now, coming to the first problem, probability of T less than 2.365 is required for nu equal to 7 degrees of freedom. So, that means we need to identify this value from the T table. For 7 degrees of freedom, for which value of alpha the T is 2.365 and we have to identify that alpha. So, 7 degrees of freedom and 2.365. Go back to T distribution table. Seven degrees of freedom and 2.365, that is associated with 0.025. So, from T table, T alpha is 2.365, that implies alpha is 0.025. So, this is the area for the given value of T and for 7 degrees of freedom. But what is the required one to find? Probability of T less than 2.365. To find this, let us draw the T curve first and consider one point here 2.365. But in T alpha, alpha denotes the area right side to that T. So, this 0.25 is this area 0.025, but it is required to find the value or the area less than left side to that T value. So, we need to find this shaded region. We know that the total probability is 1 or the total area under the T curve is 1. This is given by 1 minus probability of T greater than 2.365. So, this we can calculate from the table as 0.025. So, the answer is 0.975. Similarly, the second problem, probability of T greater than 1.318 when nu equal to 24. So, greater than means this is 1.318, greater than means right side area, and this area we can obtain directly from T table. So, for 24 degrees of freedom, T greater than 1.318, 24 degrees of freedom 1.318, so 0.1. So, the answer is 0.1. Directly we can obtain this value from the T table. Similarly, the third one, the T value lies between minus 1.1356 less than T less than 2.179 for nu equal to 12 degrees of freedom. Let us draw the graph first. So, this is some negative value minus 1.1356 and this is the corresponding the positive value 2.179. We need to find the area between these two, but using T distribution table we can find this alpha 1 and this alpha 2. Using T distribution table we can find the area to the right side of a positive value and left side of a negative value. So, for mu equal to 12 degrees of freedom, alpha 1 2.179 12 degrees of freedom 2.179. So, point not 25. This is point not 25, and alpha 2 is the left side region for this 1.1356. 12 degrees of freedom 1.1356. 12 degrees of freedom 1.1356, 0.1. So, this is 0.1. Therefore, the probability of minus 1.1356 less than t less than 2.179 is given by total area is 1 minus sum of these two values 0.025 plus 1. So, 1 minus this is 0.1. So, 1 minus 0.125. So, 0.875 is the answer. So, it is required to find right side right side area alpha 1 and left side area alpha 2. We have calculated these two values and it is required to find this shaded region. The shaded region can be obtained by subtracting the sum of these two values from 1. Similarly, the last one is a direct value t greater than 2.56, t greater than 2.567, the fourth one, 2.567 when nu equal to 17, when nu equal to 17. So, 17 degrees of freedom, t greater than value, this is 2.567 and this is the required one, directly we can obtain from t table. For 17 degrees of freedom, 2.567, 17 degrees of freedom, 2.567, here we have 0.01. So, the answer is the probability of t greater than 2.567 is 0.01. Like this, we can find the area under the t curve if t values are given. Similarly, if area is given, we can obtain t values from the entries of the t distribution table. So, in today's session, we have discussed about the sampling distribution of means when sigma is unknown or for small samples n is less than 30. And we introduced t distribution and t distribution table and how to find the area of the t values using the table. So, in the next session, we will discuss about the sampling distribution of variances. In that, we discuss chi-square distribution and F distribution. So, this is for today's session. So, we will meet in the next session. Thank you.